Hello, friends. Good morning, and you're welcome back to the channel. It's always beautiful to have you here. Today, we are also going to discuss a little bit of microbiology. And today, we are going to look at strategies that the bacteria uses to invade the immune system. Now, this is important for us it is important for us to understand that the bacteria wants to find its way into the human body and wants to use up the resources, the sugars, the proteins, the nucleic acids that are present within the human body, wants to use up all of these resources, to sustain itself and to proliferate. Meanwhile, the human body does not want these bacteria to, be able to stay within itself and multiply. And so there is this struggle between the human body, that's the immune system, and these bacteria. But for today, we want to look at some of the strategies that bacteria use, to be able to evade the immune system, to avoid detection by the immune system. This is an interesting topic. Now, just think of the human body like a bank, and then this bacterium, think of them, or bacteria, or even fungi, think of them as criminals that want to find their way into the bank. They want to blend in so that they can continue to cause havoc, steal resources and get away. Now, the first thing that bacteria could do is that some bacteria possess capsules. Now, capsules are coats that bacteria can wear. They are protective coats that bacteria can wear, and sometimes these coats are made up of polysaccharides. And these capsules are important because for some bacteria, these capsules are able to keep them safe. They can move around the whole body. The capsule helps them to avoid detection. It also helps them on the event that they are being detected, or that they are detected. It helps to protect them from being destroyed by the immune system. So the possession of capsules is a way that bacteria use to protect themselves from the immune system. Because if you have a set of two bacteria now, one has capsule and the other is naked or without a capsule, the bacteria that have capsules are more likely to, stay longer and proliferate better within the human body than the bacteria without a capsule. That's the first one. The second one is what we call antigenic variation. Now, many times the surfaces of bacteria have surface proteins. They have different kinds of proteins on their surfaces, and from exposure, the immune system is able to recognize a lot of proteins that are on the surfaces of bacteria and other pathogens. But these bacteria have also evolved mechanisms so that from time to time they change those surface proteins, they change their composition, change them around so that they become undetectable to the immune system. That is another strategy that bacteria can use to evade immune response. So all that is discussed under antigenic variation. Another thing that bacteria do is that they could inhibit phagocytosis. Now, many times bacteria know that the immune system is going to try to use immune system cells such as the macrophages, such as the monocytes, all these other immune system cells that have phagocytic abilities or properties. The immune system is going to use these cells to try to, destroy these bacteria by swallowing them up. Now, the bacteria have evolved many different strategies to block the phagocytic behavior or property of the immune system cells. Examples of such a bacteria is Yersinia pestis. Yersinia pestis is a bacteria that causes plague, black plague, and it is a bacteria that is able to avoid phagocytosis. So that is one other strategy. Another strategy is an intracellular survival. Many bacteria they try to avoid detection, but they are not lucky, or they are not successful in avoiding detection, and so they are later detected. Now, if they are detected, it's not all over for the bacteria. Many times, if they are detected, these bacteria are able to live. Now, sometimes when they are detected by immune system cells, and these immune system cells come and swallow up this bacteria. But it's not all over for the bacteria, because many a times when they live within these phagocytes, the phagocyte that swallows up the bacteria wants to secrete digestive enzymes, lysozymes, on the bacteria and destroy the bacteria. Now, since the bacteria knows this, the bacteria has also evolved mechanisms to make sure that even if it has been phagocytosed by immune system cells, it's still able to thrive and survive even within the immune system cells. It has many times bacteria could have efflux bombs, sorry, to use to push out any chemical that the phagocytes are trying to use to kill it. So this is very important, and bacteria are able to evade or are able to survive within their host. And examples of such bacteria are Mycobacterium tuberculosis that causes the disease tuberculosis. Also, we have the production of enzymes. Some bacteria are able to produce enzymes, and these enzymes have the capacity of degrading or destroying host antibodies. Now, I don't want to dive into immunology now because we know that the production of antibodies is what the immune system uses to tag or to detect for the presence of pathogens. Now, if these pathogens are able to, destroy these antibodies, they're able to reduce the risk of being detected by other immune system cells and being destroyed. So this is also important to note. Okay, then there's also what we call molecular mimicry. Molecular mimicry. Some bacteria have the ability or capacity to express molecules that are similar to their host tissues. So they can have molecules that are similar to their host tissues that they secrete. And this makes it difficult for the host tissues to be able to identify the bacteria different from the normal body cells. So, this is what we call molecular mimicry. So it makes it difficult, just like you have mimicry when you are talking about camouflaging and trying to survive in biology. So the bacteria also do something like that. They secrete molecules that are similar to molecules that are secreted normally within the human body, thereby making it difficult for the immune system to differentiate them from other cells. Lastly, there is biofilm formation. Biofilms are complex molecules of um, microorganisms or bacteria, and these biofilms, these communities, are designed in such a way that they provide protection. They provide protection against the host cells. So biofilm formation is very important because when the bacteria lives in a biofilm, it lives in a community, and so it is protected from desiccation. It's also protected from the effect of the immune system cells. They are not able to get close to this bacteria and destroy this bacteria. Many bacteria have been known to form biofilms on many surfaces and objects. Thank you for listening to this. I hope you've gotten a thing or two about the strategies that bacteria use, the strategies which bacteria use to avoid detection. Thank you for listening to this. Remember to like our content, share our content, and remember to follow us on all our platforms and have a wonderful day.